We have discussed 3 sample papers, and in this lecture we are going to see sample paper 4. So questions I'll be discussing regarding physics and chemistry. So first question, if you observe, consider the following table. They have given 3 atoms: carbon C, hydrogen H, chlorine Cl, with electronic configuration 2, 4. So atomic number is 6 for carbon. Hydrogen atomic number is 1, and electronic configuration for chlorine is 2, 8, 7. That is nothing but 17. Okay, they are asking 2 questions. Draw the electron dot structure of a compound formed with 1 C atom and 4 H atoms. So if you observe carbon, and if you want to draw electron dot structure, try to understand. To draw this electron dot structure, we have to take only electrons which are in outermost orbit. So outermost orbit electrons only we need to take. If you observe carbon, it is 2, 4. So outermost orbit is 4. So we have to draw 4 electrons. And while coming to another thing, they are asking with 1 carbon and 4 hydrogen atoms. And while coming to hydrogen, that is only outermost orbit, and it has only 1 electron in its outermost orbit. So how we can draw carbon with 1 electron, second electron, third electron, and fourth electron. And while coming to hydrogen, we can draw hydrogen with H with 1 electron here, hydrogen with 1 electron here, hydrogen and another hydrogen with 1 electron. Now this hydrogen will share 1 electron from carbon, hence 1 bond is formed. This hydrogen will share 1 electron from carbon, 1 bond is formed. So same thing happens for all the hydrogens. So each hydrogen will share 1 electron from carbon. Like that, hydrogen will be satisfied. And while coming to carbon, carbon will share 1 electron from every hydrogen, hence it will form 1 bond here. So this bond is known as covalent bond. So you see, for one question, I am giving you multiple inputs such that we can use those concepts for other questions also. You see, different concepts we are learning from one question. Covalent bond. So covalent bond is nothing but bond formed between 2 atoms by sharing of electrons. There is no transfer. If electron is transferred, that is known as ionic bond. So like that, bond is formed whenever you are drawing a circle. Either it has to satisfy duplet electronic configuration or octet configuration. Duplet means 2 electrons, octet means 8 electrons in the circle. If you observe all hydrogens, it will have duplet. While coming to carbon, octet, 1, 2, 3, 4, 5, 6, 7, 8 electrons in the circle, like that. Second one, the type of bond formed between C and Cl. So what type of bond formed between C and Cl, C and Cl, and they are asking to draw, right? So while coming to carbon, 1, 2, 3, 4 electrons in its outermost orbit. While coming to chlorine, chlorine is 17, so outermost orbit is 7. So you can draw like 1, 2, 3, 4, 5, 6, 7, right? So like that, it has to satisfy everything. Cl, same, 1, 2, 3, 4, 5, 6, 7. Here we will get chlorine, 1, 2, 3, 4, 5, 6, 7. Here we will get chlorine. So like that, same, like in place of hydrogen we can place chlorine. That also we will be getting diagram. And if you see explanation, so this is the diagram for 1 carbon and 4 hydrogens. And while coming to this one, here also carbon and chlorine both will be sharing electrons, hence we will be getting covalent bond. This is the hint, covalent bond you have to underline. And you see, it share 1 electron with each 4 chlorine atoms to complete it octet. So both will be satisfying octet rule. Like that, we have to write the answer. So I'll coming to second one. A part of periodic table is given, group 1, group 2. Okay, group 1 elements, group 2 elements. Guys, you see, don't get confused. Periodic table will be like this. So this is group 1, this is group 2. So lithium, of course, first element is hydrogen. They are not mentioning hydrogen. They have mentioned from lithium, sodium, potassium, rubidium, cesium, francium. Group 2, beryllium. Okay, few blanks they have given, and radium they have given. That leave it. They are asking questions like, how does the tendency to gain electrons change as we go down the group? You see, the tendency to gain electron change as we go down the group. If you're moving down, a tendency to gain electron, tendency to lose electron, simply to say valency. So they're talking about valency. How valency changes if you're moving from top to bottom means valencies will be constant. So why all elements are placed in group 1? Because all these elements will have only one valency. Why all these elements are placed in group 2? Because all those elements will have two valency, so that valencies will be constant, so the tendency will be constant. So give the reason means that is the reason. So you can observe, on going down from lithium to cesium, electron gain tendency of element, you see why, you see wait, on going down the group, tendency of element decreases due to increasing in size of element with increasing in. Okay, fine. So simply to say tendency to gain electrons. Okay, sorry, they are not talking about the valency, they are talking about the non-metallic character. Non-metallic character. So how does the tendency to gain electron? That's it, na? Metals. Metals always it will be losing electron. Non-metals will be gaining electrons. Yeah, they're talking about gaining electrons. Gaining electron in the sense we have to talk about non-metallic character. So as how that non-metallic character change if you go down. So non-metallic characters will be decreasing. Non-metallic characters will be losing. So that character will be decreases if you are moving from top to bottom. That is the reason. Why? Because so if you are moving down, extra orbit is added. When extra orbit is added, extra electrons are added, so that it will be decreased. Next, how does the valency, okay, now they are talking about valency, vary as we move vertically downwards? That valency will be, so before I have said na, that valency will be constant if you are moving from lithium to cesium. Give the reason. So the valence of the group remains constant. Why? Because all elements are placed in group 1, so valency will be 1. If you write electronic configuration, it will be ns1. So for example, if you take lithium, its atomic number is 3. If you write electronic configuration for 3, it will be 2, 1. If you write, you see sodium, electronic configuration is 11. If you write electronic configuration, it is 2, 8, 1. Potassium atomic number is 19. If you write electronic configuration 2, 8, 10, 18, 1. If you observe 1, 1, 1, valency is 1. So that valencies will be constant if you are moving from top to bottom. So previously I have said na, so that you can keep that statement for this and non-metallic character for this. Now third bio, 4 bio, 5 bio, sixth question. Figure A shows the arrangement of the setup and figure B shows the result of the experiment. Okay, so if you take one paper and if you insert one copper wire, sprinkle few iron fillings and connect that copper wire to a battery. So as soon as connecting it to the battery, what happens? Around this conductor, magnetic field is produced. Because of the magnetic field, if you tap this cardboard 4 to 5 times, automatically all iron fillings will be arranged in one pattern. That pattern is concentric circle pattern. Why concentric circles are formed means because around the conductor, around straight current carrying conductor, magnetic field will be in circular shape, so that only all iron fillings will be arranged in circular pattern. That is a concept you have to understand. That thing should strike in your mind. Okay, number 1 question. What does this concentric circle shows? Concentric circles will be showing magnetic field around the conductor. Number 2, which rule gives the direction of these circles? So few things you have to remember whenever they are asking about direction. So you have to think what directions. In case of the direction, if they are talking about current and magnetic field. So if you find only current and magnetic field, then we have to talk about right hand thumb rule. Right hand thumb rule, or you can call this one as Maxwell's thumb rule, Maxwell's corkscrew rule, whatever you want. While coming to direction, if they're talking about direction of current, direction of magnetic field, direction of force, if 3 things are included, then answer is Fleming's left hand rule. Fleming's left hand rule. Now they're talking about what? Rule, direction of circles. Direction of circle means simply to say the magnetic field. Why magnetic field is produced? Because of electricity, right? So 2 we have, answer will be right hand thumb rule, and we'll see answer also how they have given. If you observe the 6th one, the concentric circles formed around the wire carrying current shows the direction of magnetic field. You see, this is main important. So whatever you write, maybe 2 lines, 3 lines, 5 lines you write. try to underline the direction of magnetic field, because straight away he will correct this. Next, the direction of magnetic field around current carrying conductor is given by. So here also 3 lines are there. Right hand thumb rule, try to underline this. So to write this one, you will get 1 mark. If you write right hand thumb rule, you will get 1 mark. Total 2 marks will be assigned. Like that, we need to answer. And internal choice question we have. In an experiment, there are 2 coils. Okay, coil 1 and coil 2. Wound on non-conducting cylindrical rod. Fine. Initially, key is not inserted. So here in this key socket, key is not inserted, it seems. Discuss the case. Number 1. When key is inserted, when key is removed. Simple. When key is inserted, what happens? Just for a fraction of a second, that current is passed. Current passed through the coil 1. When current is passed, magnetic field is produced for an instant. For an instant, magnetic field is produced. And this magnetic field will show impact on this coil 2. When magnetic field is showing impact on coil 2, automatically current is induced. Current I is induced. Because of current is induced, that you see, that is not continuous. Because of not continuous, as soon as key is inserted, that galvanometer will deflect. Just it will deflect and it comes to original position. So when key is inserted, what happens? It will deflect and then comes to original position. Why? Because you see, this coil 2 is at rest. Coil 1 also is at rest. I told you, coil as well as magnet. Coil and magnet. If coil is in motion, magnet is at rest. Yes, we can observe continuous deflection in galvanometer. If coil is at rest and magnet is in continuous motion, yes, we can observe continuous deflection in galvanometer. If coil is at motion, coil is in motion, magnet also is in motion, then also you can observe continuous deflection. Now, when coil is at rest, magnet also is at rest, then you cannot observe continuous deflection. Now you see, this is at rest, coil 1 is at rest. You are talking about magnet, but there are 2 coils now, of course. Coil 1 magnetic field is produced now. So you can consider that one as a magnet. You can consider that one as solenoid. That is also magnet. Because both are at rest, we will get just deflection and comes to original position. Next, number 2. When key is removed, as soon as key is removed, opposite flow will be there. So that what happens? Again, it will deflect. But now the deflection will be in opposite direction. It deflects, but in opposite direction. It deflects, again comes to original position. That is the answer you have to write. You see internal choice. When key is inserted, the magnetic field produced due to current in the first coil, the EMF, electromotive force, or electromagnetic field is produced in second coil due to, EMF is produced due to change in magnetic lines, so that there will be deflection in galvanometer. Next, when key is removed, again magnetic lines of forces will decrease and direction of induced current will be changed. It will be reversed, so that galvanometer will show opposite direction. It will show opposite direction. That is the answer we have to write. Seventh bio. Okay, next 8th question. 3 marks question. 3 questions are there. Each question carries 1 mark. Calcium is an element with atomic number 20. State the reason for each of the following questions. There are 3 questions. Number 1. Is the given element metal or non-metal? So if you write electronic configuration for 20, it is 2, 8, 8, 2. In outermost orbit, there are only 2 electrons. And if there is 1 electron, 2 electron, that element will be ready to lose electron. So which element will be losing electron means obviously it is metal. Okay. They didn't ask you to write the reason, na? So no need to write reason, just I am telling you the reason. Or if you observe placement of calcium in the periodic table, here we have hydrogen, here we have lithium, sodium, potassium, lithium, beryllium, sodium, magnesium, potassium, calcium. This is the area where we can call it as metals, na? So placement of metal in the periodic table, I mean placement of calcium in the periodic table, that gives information that calcium is metal. So they are asking, is the given element metal or non-metal? You have to write answer metal. That's it. No need to give explanation. So answer can be very short and sweet. Number 2, will its atomic radius be larger or smaller than that of the element with atomic number 19? You see, calcium atomic number is 20 and 19th element is there. We don't know X. Okay, if you know, it is potassium. They are asking, will its atomic radius, whose atomic radius? Calcium. Calcium atomic radius be larger or smaller than that of element with atomic number 19? So atomic radius, atomic size, if you are moving from left to right, definitely it will be decreased. Why it will be decreased? If you are moving from left to right, atomic number is increasing, When atomic number is increasing, proton count also will increase. When proton count increases, nuclear charge also will increase. When nuclear charge is increasing, automatically that nucleus will pull all the orbits towards the nucleus. Na? Because of the pulling, automatically size is decreased. So calcium will be smaller. That is the answer you have to write. So answer is smaller. Number 3, write formula of its oxide. Whose oxide? Calcium's oxide. So we know calcium Ca, oxygen O, calcium Ca, oxygen O, calcium atomic number is 20, valency is 2, oxygen atomic number is 8, valency is 2. The 2 goes to calcium, it becomes Ca2. 2 goes to oxygen, it becomes O2. If there are similar numbers, you can cancel it, and at last you can write it as CaO. That is the oxide of that particular element. Ninth question. 1. Which element exhibit the property of catenation to maximum extent? Why? So catenation, tetravalency, these are the words you have learned in 4th chapter, carbon and its compounds. So blindly you can write answer carbon. So what is meant by catenation? It is self-linking of same element to form long chains, branches, rings, etc. So they're asking why. Here you have to write the reason. Because of tetravalency, it cannot lose electron, it cannot gain electron, it can share electron. Carbon is the element which will be undergoing covalent bonds, most probably covalent bonds, so that it will be exhibiting the property of catenation. If you want, you can see answer also, like how you need to write. Okay, for previous one, 8th one. So whatever you write, answer is calcium is metal. You have to underline that metal. So it has 2 electrons in outermost orbit and valence electron it can easily lose. No need to write the reason for the previous one. Potassium is placed before calcium, same period, both have same number shells. Okay, you see, unnecessary thing. Okay, why they have given here in the sense? To understand. Since the atomic radius decreases from left to right, you see, this is the reason. Decreases from left to right. Thus, atomic radius of calcium is smaller. We have to underline that smaller. And third one, answer is CaO. Okay, well, coming to 9th one. Answer carbon. Write that one and underline that carbon. Exhibits the property of catenation to maximum extent in the periodic table due to small size and strong carbon-carbon bonds are formed. You can write whatever reason you want, you can write. It has the capacity of tetravalence, you can write. So it cannot lose electron, it cannot gain electron, it can share electron, covalent compounds. So why it is strong? Covalent compounds between carbon and carbon is so strong. Whatever reason you want, you can write. Next, B. Write molecular formula for the second and third member of the homologous series whose first member is CH4. So 1, 2, 3. And first member is CH4 they have given. We have to write second member and third member. They are talking about homologous series. Na? Homologous series in the sense it is a series where molecular formulas will be differed by CH2 units. Right? That's what we have discussed. You guys have learned in alkanes, CH2 units. So for C, if you add another C, it becomes C2. For H4, if you add 2 hydrogens, it becomes H6. Again, for this, for C2, if you add 1 carbon, it becomes C3. And if you add two hydrogens, it becomes H8. That's it. You can leave CH4, CH2, C3H8. You see, C2H6, C3H8. Those are the answers you have to write. What they are asking? Write the molecular formula. That's it. They didn't ask you to write the name. Na? So here you can write just C2H6. No need to write it is ethane. C2H6. No need to write it is propane. If you want, you can write it. No worries. If you don't write also, they will not deduct any mark. So no need to worry with that. Next, number 3. Which property of carbon is responsible for carbon's ability to form unsaturated hydrocarbons? So why it will be forming long chains, branches, rings? Why it will be sharing all the electrons? Because carbon forms unsaturated hydrocarbon with multiple bonds are present, since carbon has small size and it has tendency to form multiple bonds. Why? Because of tetravalency. You can write tetravalency, the word. You can represent. Next, internal choice question. From which of the following elements, lithium, magnesium, oxygen, fluorine and potassium, select the element having 2 electrons in its outermost shell. 2 electrons means if you write electronic configuration, there should be 2. So if you write lithium electronic configuration 2, 1, so it is 1. Magnesium 2, 8, 2. Yes, we have 2. Oxygen 2, 6. So there is no 2. While coming to fluorine, so like that if you write everything, okay, for fluorine 9, 2, 7. For potassium 2, 8, 10 and 8, 1. Right? So answer is magnesium. Second one. Select the two elements that belongs to same group. Same group means you have to come down. So if you see the placements, so that only I've been telling you in sample paper 1, 2, 3 also I told you. Learn 36 element placements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, okay, you leave this one. And they have given what? Lithium. Okay, here we have lithium. Magnesium, here we have magnesium. Oxygen, somewhere here. Fluorine is here. Potassium K, here we have potassium K. So they are talking about select the two elements that belongs to same group. Same group means you have to come down from top to bottom. Here if you observe, we got lithium, potassium in the same group. So answer is lithium and potassium. Next, third one. Write the formula and mention the nature of compounds formed by union of 19 potassium and element X having atomic number 17. So potassium K, which is 19, and some X element with 17. 17 means it is chlorine, right? So Cl with 17, potassium with 19. You see, potassium is metal, always it will be losing one electron. So potassium will be losing one electron. Chlorine, it is non-metal, always it will be gaining one electron. And if it is sharing, we are talking about covalent bond. Now losing and gaining of electrons refers ionic bond. So what they are asking, write the formula. Okay, how to write formula? Potassium with one valency, chlorine with one valency. So one will go to chlorine, here one goes to potassium, it becomes KCl. Potassium chloride is the chemical formula. And mention the nature of the compound. Nature of the compound is ionic bond, simply to say ionic compound. That's it. So we'll see internal choice here. So answer is magnesium has 2 electrons. Number 2, lithium and potassium belongs to same group. We have to underline that. And while coming to this one, potassium chlorine, answer is KCl or KX, both. However you want, you can write it, no worries. Okay. In question they have asked the X element, na? So it is better to write KX. So what happens if I write KCl? Nothing, you will get mark, don't worry. And its nature is ionic in nature. It's enough. Like that you need to answer that. Now 11th question. Diagram shows the lengthwise section of current carrying solenoid. Okay, so they have given just a box and they have represented A and B. Now indicate current entering into the page. So you consider this AV box is a page. Indicate current emerging out of the page. Okay, now you can redraw the diagram like this. This is A, this is B. Now here we have cross mark. So cross mark, what? This cross mark indicates current entering into the page, means current is entering like this. This dot indicates current emerging out of the page. So this is current emerging out. You see, current is coming inside in the sense, let me zoom and draw. You see, current is entering like this, isn't it? And this is showing current is going out like this. So simply to say, current is coming like this and it is leaving. So if you trace the path, so here also current will be coming like this. That's it, na? So currents are coming, going like this, and from B current is coming out. From A current is going inside, from B current is coming outside. So that is the information which they have given. So this is just information. Now let us try to solve the answers. Okay, first question. Decide which end of the solenoid, A or B, will behave like North Pole. I told you many times, when currents are entering, that is positive terminal. When currents are leaving, that is negative terminal. Whenever there is negative terminal, that side there will be north. When there is positive terminal, just to remember, negative starting with the letter N, north starting with the letter N. So north, north. So positive terminal, that is south. Now which end of the solenoid, A or B, behaves like north pole? B behaves like north pole, that is the answer. Draw field lines inside the solenoid. Inside the solenoid, many times you might have learned, you see current, when current is passed, what about the magnetic field? Magnetic field outside, it will be like this. Outside the solenoid, it will be like this, and while coming to inside, it will be parallel to each other. So magnetic field lines will be parallel to each other like this. So that is the answer you have to write. So you see question number 11, right? So number 1. So A represents, why it is North Pole? No, definitely this A is South Pole and B is North Pole. You can correct it. Next, so field lines inside the solenoid will be straight, parallel lines. Like that you have to draw the diagram, or you can solve the answer.
Your voice is.
Now we have this one, section B. Okay, already we did this. Okay, 12th question. Two wires of equal lengths and diameters, one made up of copper and another made up of nichrome, are connected. Okay, copper nothing but it is a metal. Nichrome, it is nothing but an alloy, are connected as shown in the figure below. Current through both wires are increased gradually. Okay, you see here copper is metal, nichrome is an alloy. Both are connected in series. When both are connected in series, okay, they are asking questions, and you see current through both wires is increased gradually. In series, voltages will be varying. Voltages will vary, and while coming to current, it will be constant. So same amount of current is passed through copper, same amount of current is passed through nichrome. Number 1, explain which wire will heat up faster. It is quite simple. Metals are good conductors. Metal is a conductor. So for conductor, resistance will be very least and current passage will be more, so that heat energy will be less, right? And while coming to alloys, resistance will be high, so that current will be opposed, it will be least, so that heat energy will be more. So from this easily we can tell, explain which wire will heat up faster. Nichrome will heat up faster. Why? Because it is an alloy. For alloys, resistance will be least. Well, coming to 2, what will happen if both wires are connected in parallel? You see, this is copper, this is nichrome. When connected in parallel, what happens, they are asking. So in parallel circuit, we know voltages will be constant and current will vary. Now you see, current is passed through copper and current is passed through nichrome. How much required current is needed, that much only it will pass. Now in this condition, copper, it will pass huge amount of current. Now you see, copper is metal. When copper is metal, it will pass high amount of current, and while coming to alloy, it will pass least amount of current. When high amount of current is passed through copper, automatically some amount of heat is generated in copper than nichrome. So in the second condition, copper will get heat, copper will be heated. So that is the answer. So you can observe the answer here. So, and internal choice, find equivalent resistance. You see, when a circuit is given like this, don't get confused. First of all, try to solve the system which is in series. You see, these two resistors are in series, right? Try to solve these two. So if you solve these two, that circuit becomes like this. This is A. So here we have a junction, this junction. So, and also you see, these two resistors are in series. 3 and 2, these two resistors are in series. Solve it and solve it like this. So 3 plus 2, both are in series now. 3 plus 2 is 5 ohm. Now this resistor will be as usual, this middle one. So draw like this. So what is the capacity they have given? It is 3 ohm. Now these two resistors are in series now. So solve this. 2 plus 4, 6. So this resistor will be like this. 4 plus 2, 6 ohm. Now here it is connected to 2 ohm. Now you see we got system which is in parallel. Now try to solve these three resistors in parallel. 1 by R is equal to 1 by R1, 6 plus 1 by R2, 3 plus 1 by R3, 4 plus 2, 6. Right. Sorry, 3 plus 2 is 5. 5. 3 plus 2 is 5. This is 5. 5. Now 1 by R is equal to LCM. 6 2 is 12, 6 3 is 18, 6 4 is 24, 6 5 is 30. 30 is the LCM. 5 6 30 plus 3 10 30 plus 6 5 is 30. So 1 by R is equal to 6 plus 5, 11, 11 plus 10, 21. 21 by 30 and R is equal to 30 upon 21. So 3 10s 30, 3 7s 21. So 7, 10, 7 1s 7, 3.0, 7 2s 14, 7 4s 28, 2 0, 7 2s 14. So it will be going on 6, it will be going on 1.42. You can round it off. So after solving this entire system, we got a circuit diagram like this. This is A. So at last we got one resistor. So with value 1.42, and you see this resistor. You can draw like this. That is 2 ohm. Now these two are in series only, not in parallel. Don't get confused. You don't have any junctions. Now 1.42 plus 2, it becomes 3.42. So entire system equivalent resistance is 3.42 ohm. So do we have? Right. So of course we got 24 by 7. If you do that also 724, 7 3 is 21. LCM is 3.0. 7 2 is 14, 7 3 is 21, 7 4 is 28, 2 0, 7 2 is 14. It will be going on. You see 3.42 only we got. Here also we got 3.42. Whatever you do, however you do, answer is same. So like that we have to solve the question. So I'll do one thing in next lecture. We'll see this sample paper 5, next sample paper. At the same time, I'll explain you this 15th question. So I'll explain 15th question and then I'll move to sample paper 5. That's it in this lecture.